Drop a 1,000-pound cow into the deep ocean, or toss a fish onto a dry, dusty pasture. Both would fail immediately because of a structural mismatch. Earth consists of distinct, unforgiving environments, each with its own physical requirements. We call these habitats. To survive in a specific habitat, an organism must possess physical traits that address the specific pressures of that neighborhood. Every physical feature you see on an animal or a plant, from the shape of a leaf to the number of legs, is an adaptation designed to solve a specific environmental problem. To see how these requirements change across just a few feet, we can look at a single border where land meets water. On the grassy bank, we find terrestrial animals. Living on land presents two primary physical challenges: the constant downward pull of gravity and the need to move across hard, solid surfaces. The terrestrial solution is rigid architecture. These animals have evolved dense bones to support their weight and strong legs to propel themselves across the ground. There is also the problem of oxygen. On land, it exists as an invisible gas in the atmosphere. To access it, these animals require internal structures, like lungs or spiracles, to pull the air in. Terrestrial bodies are weight-bearing machines built to fight gravity and extract oxygen from the air. Plants face these same gravity and wind pressures, but without the ability to move to a different location. To reach sunlight, trees build massive, hard, woody trunks. This rigid structure allows them to elevate their leaves while resisting the pull of gravity and the force of the wind. Shrubs, like this rose plant, solve the same problem at a smaller scale, using many brown, woody stems that branch out close to the ground. Herbs, like the tomato plant, remain close to the soil, relying on soft, green, pliable stems. To breathe, terrestrial plants use stomata, microscopic pores on the leaf surface that allow air to move in and out. Once the air is inside, the leaf must act as a solar panel. In a banana leaf, this parallel venation acts as internal scaffolding, supporting the leaf tissue against gravity so it can catch the sun. From trunks to veins, terrestrial plants invest biological energy into building rigid physical structures just to stay upright and breathe. Cross the shoreline boundary, and the physical rules of survival change instantly. Underwater, buoyancy supports an animal's weight, making gravity less of a threat. Instead, the primary obstacle is water resistance, or drag. Aquatic animals solve this with streamlined bodies. This sleek profile allows them to slice through the heavy liquid without wasting energy. Walking legs are replaced by fins to generate thrust, and internal lungs are replaced by gills to extract oxygen directly from the water. This shift also applies to plants. In a moving river current, a hard, rigid tree trunk would likely snap. Aquatic plants utilize flexible, soft stems. They yield and bend with the flow of the water rather than fighting against it. Their leaves often function as flat rafts, designed specifically to float on the surface to access sunlight. Some creatures possess features for both worlds. A frog has webbed feet that act as flippers underwater, combined with muscled, rigid legs used to push against gravity on land. Aquatic bodies are engineered to slip through and bend with a dense, flowing liquid. In the living world, form follows function. A habitat is a set of physical problems. An organism's body is the solution. The variety of life we see at this pond reflects the different physical requirements of land and water. Now, it's your turn to apply the habitat rule. Consider this mystery creature. It possesses highly webbed feet, a thick layer of waterproof blubber, and a streamlined body. Tell us in the comments, is this creature built for the terrestrial world or the aquatic world? Use the features we've discussed to explain your choice.